A protein grabs this sugar, changes shape, and hauls it across. So the cell is burning ATP. That sentence costs more marks than anything else in Unit 2. It moved. The cell paid nothing, not one molecule of ATP. Two traps live in this topic, and one question kills both. Give me 3 minutes. Here's the setup. Glucose is piled up outside the cell and scarce inside. It is already being shoved inward. Steep gradient, constant thermal motion, all pushing the same way. So what's missing isn't energy. What's missing is a road. Hold on to that, because it decides every answer for the rest of this topic. The first fix is the blunt one, a channel protein, a water-lined tunnel punched straight through. Open it, and potassium pours out down its gradient, millions of ions a second, through one pore. And it's fussy. A potassium channel turns back sodium, an ion that is actually smaller. Many channels are gated. A signal binds, the door opens, and the traffic starts. But a gate is a switch for timing. It never decides which way, and it never picks up the bill. The other door never opens a tunnel at all. A carrier has a pocket, and the sugar clicks into it. Watch the middle of the cycle. For a moment, that pocket is shut on both sides at once. Then it opens on the far side and lets go. Bind, flip, release, reset. One passenger at a time. And there it is. Moving parts, machinery. The mind quietly fills in a fuel line. But the flip is powered by the sugar binding. It's a turnstile, nudged by whoever walks in. So let's audit it. Both doors open, both moving solute, at the same time. ATP hydrolyzed by the cell. 0 through the channel and 0 through the carrier. The gradient paid. That concentration difference is stored energy, and diffusion is spending it. Facilitated is a rotten word. It sounds like the cell leaning in. It only means the path was eased. Downhill is free, with a protein or without one. The hardware was never part of the question. Then how would you ever tell a protein was involved? Raise the concentration and watch the rate. Simple diffusion is a straight line forever. The carrier curve climbs, bends, then goes flat. Because there are only so many carriers, and every single pocket is already occupied. That plateau is not an empty fuel tank. It's a full car park. Put the whole unit on one axis. ATP spent per 1,000 solutes moved. 3 of these 4 run through a membrane protein. 3 of them cost the cell nothing. The pump pays because it goes uphill. Uphill is the only reason anything ever pays. Now let facilitated diffusion just run. Outside falls, inside rises, until the 2 sides match. And now it has stopped. Right? No, both carriers are still cycling. The crossings didn't stop, they canceled. A carrier can't see the far side. It binds whatever arrives, equally often from each direction. So here's the entire topic as one question. Which way is the solute going relative to its gradient? On the exam, the shape change is the bait. The direction is the answer. Read for the gradient first. A protein is a door, not a pump. An equilibrium is balanced traffic, never a parking lot. Want to step through this one yourself? Links below.